All right, guys, we will try to do this very quickly. We are, oops, that's not what I want. We are going to be doing 7.2, which is compound interest and half-life. So pull those notes up if you have not already. The formula for compound interest looks horrible. It's really not so bad. This is what it looks like. So A is your amount of money. Excuse me. P is your principal, your starting amount. R is your rate, which you're going to put in as a decimal. So if it's 2%, you'd put in as 0.02, right? And then this N down here and this N up here is the number of times it is compounded. And then T is the time that we're talking about. So I'll explain that as we go, what gets plugged in where. Here we go. So first example, it says you loan someone $400 at 6% interest per year. How much will they owe you after 1 year if it's compounded annually, quarterly, monthly, and daily? Okay. So annually, you are going to do the principal amount. That's your starting amount, the 400 times, and then it's 1 plus, now it's your interest rate. So your interest rate is 0.06, right? 6% would be 0.06. Technically, that's over 1. Okay. So you don't need to put that in for this one. If it's annually, whenever it's annually, this is going to be over 1. And then your N up here is 1 times the amount of time. So for one, compounded annually, for 1 year, after 1 year. So 1 times 1. So if we simplify this, really what you're doing is 400 times 1.06 to the first power, if you want to think of it that way. When you plug that into your calculator, you get $424. So if you loaned someone $400 and they're paying you back at 6% compounded annually, after a year, you would have made $24 off of that, right? They paid you for 24 instead of the 400 they borrowed. Okay, so quarterly then. If it's quarterly, we're going to go 400, right? That's our P, times 1 plus, it's still 0.06, but quarterly means 4 times a year. Okay, quarter, 4 quarters in a dollar. So this is going to be a 4, and then we're going to take that to the 4 times 1, because we're still talking 1 year, right? T is our time, 1 year. So if you plug that into your calculator, you will get, where's my calculator? And you don't need to put parentheses here. It should, you have to put these parentheses. Whoa. You should not have to put parentheses around this. It should do that for you when you're plugging it in, but you get $424.55. Okay, so you make a little bit more money the more it compounds, if it compounds quarterly. So monthly, it should go up again, right? You take your original, your principal amount, 400 times 1 plus, this is 0.06. Monthly, think about how many times that is. If it compounds monthly in a year, that would be 12 times. And that's to the 12 times 1. So again, plug that in as you see it. What you get when you plug that in is $424.67. Okay. And plug this stuff in, make sure that it's working for you, because sometimes you think, oh yeah, that's easy. And then you actually go to do it and you're getting very strange, wrong numbers, and you don't know it until come test time, and then it's marked wrong. So plug this in with me right now. Make sure that you're getting what I'm getting. If you're not, reach out to me. Okay, daily. If we are doing this daily, we take our principal amount and then it's 1 plus the rate, 0.06. We're talking daily for a year. So that would be 365. Okay, and we would take that to the 365 times 1. Plug that in. you should be getting 424.73. Okay, so it's not a huge difference with this like small amount of money. When it's a bigger amount of money, it feels like a bigger difference. But that's what you'll get when you compound annually, quarterly, monthly, daily. Okay. Okay, so that's compound interest. When they say something is continuously compounded, there is a special formula for that. We call it Pert because it looks like Pert. But it's A equals PE to the RT power. Okay, so PE to the RT. P is your principal, that's your starting amount. E is a constant, it's a number. It's just not a number we want to have to plug in. It's kind of like pi, okay? If you look on your calculator, there is a E as a second to the division symbol. If you plug that into your calculator, just E and hit enter. So you would go second, divide, enter. You get 2.71828182. It's this number. So we say it's about 2.7. Don't use 2.7, use E. Okay, we want the exact. R is your annual interest rate. T is your time. Okay, so I'm going to show you how we work with Pert. Example 2 here, it says, suppose you have $3,000 in an account that pays 2% interest, compounded continuously. Okay, so when you see that, you need to think A equals PE to the RT. Okay, how much will you have in 4 years? So we say A equals, P is our principal, so that's your starting amount, 3,000. E is the number, 2.7, so on and so forth. We're going to call it E. R is our interest rate. That's 0.02, right? 2% as a decimal is 0.02. And then T, that's our time. And it said 4 years. So you're going to plug that into your calculator. I'm not going to show you on my calculator. I'm just going to explain it to you. If you don't get it, send me an email. I can set up a time to do it with you. Yeah, otherwise we're jumping back and forth so much. So you are going to plug into your calculator. I'll actually do it like this. This is every button you'll push. So you'll type in 3,000. There's E in 2 different places. It is the second key. So it's always going to be second something. So the blue button and then the LN on the far left of your calculator, or the blue button and the division symbol on your calculator. Now, if you do the LN one, it has the exponent already. So I like that one. So you would plug in 3,000, then you're going to hit second. Then you're going to hit the button that says LN, because right above LN is this in blue. Okay. That's what we're looking for. So second, the LN, natural log, button. And then when you do that, it takes you superscript so that you can type in 0.02. So 0.02, and then the times button, and then 4. And then hit enter. Okay, so that's how you would plug this in. What you get is that amount is $3,249, and we're talking money here, so round it to the nearest hundredth, and 86 cents. Okay. Okay. Where it gets a little more challenging is when they ask you how long will it take. This is a little fancier. So how long will it take for $3,000 at 2%? Now you're going to do either guess and check, or you can graph. And this one I actually will show you on the calculator so you can see it. How long will it take for 3,000 at 2% compounded continuously to double? Okay, so think about what that means. If we started with 3,000, the amount that would double is 6,000, right? So we would say 6,000, because that would be doubling it, should equal 3,000 P times E to the R, 0.02 is our rate, and T is our time. Okay, we don't know what that's going to be. So I would first simplify this a little bit. I would divide by 3,000 on both sides because we're trying to figure out what t is here. So we get 2 equals e to the 0.02 t. Okay, now here are your options. You can guess and check, which some people like better, or you can plug it into your calculator, which others like better. I'm going to show you both. You can choose. Okay, so if I'm going to guess and check, we're going to say, okay, well, how long do I think it would take compounded continuously to double? Okay, so you kind of just have to pick a place to start. Maybe it would be 20 years. So if I plug in E times 0.02 times 20, okay, what I'm looking for is I want a number here that is 2. Okay, so let's plug in 20. So you would go second, the ln to get e to the power, and then 0.02 times 20. Okay, that comes out to 1.49. So it's not quite 2. Okay, so we need to go bigger. So let's try 40. Okay, now here's the thing. On your calculator, if you just hit second enter right now, second enter, it will give you that back. And then all you have to do is go back and change the time. So it was a 20. I just need to make it 40 now and hit enter again. And now I get 2.2. So for 40, I got 2.2. For 20, I got 1.49. Okay, so it's somewhere between 20 and 40. So maybe try 30. Second enter. Change that number to 30 now. And when I type in 30, I get 1.8. Okay, so that's low now. So it's somewhere between 30 and 40. Try 35. Second enter, change that to 35. I get 2.013. Okay, so that's pretty stinking close to 2. Try 34 just to check. Second entry, 34. That's 1.97. Okay, so this is our winner because that's where we passed the 2 threshold. So how long would it take? It would take 35 years. Okay, now if you don't want to do it that way, let me show you how you could graph. I need to share my calculator here. Okay, so if you're going to do it this way, then you go to y equals, and you would put in, we're going to the e, so second e to the x. Oh, I forgot to clear out my other stuff. Hold on. Second e to the x, and then it's going to be 0.02. And we're just going to call tx. Okay, we just need a variable there. And then your y2, so go down to your y2, and that's going to be 2. So you've done this before. You take both sides of your equation, make one y1, make one y2, and we're just going to find the intersect. So what you do is you go second, trace 5, and it will graph your intersect. Oh, I didn't think about this. Our window is off. Okay, think about what makes sense with your window. So if you don't see anything here, if it didn't work, change your window. First of all, we're not going to have negatives, so you can make your x minimum 0. Your x max, we're talking about how long it will take. So at this point, we don't know. Pick 50 or 60 just to be safe. And then our y, go down to y, we're not going to be below 0 there. And then we know that our y value max is at 2. So I'm just going to make my y max 5. You could leave it 10. It wouldn't be bad to leave it as 10. Okay, so that's my window. Now type in second trace, and 5 is going to give us the intersect. That's better. Now you can see where they meet. Remember this one? First curve, question mark. Yep, hit enter. Second curve, question mark. Yep, hit enter. Do you want me to guess? Yes. Notice what happens, 34.6. That means it's going to take 34.6 years. So at 34 years, it's not there yet. So it would have doubled by 35 years. Okay, we would round that up. Okay, stop sharing that. Let's reshare the notes. Okay, so that's that. Last thing is half-life. And with half-life, there is an equation again. Half-life is just how long something takes to decompose to half of its value. So this is the formula that you're going to use for half-life. A, just like P equals ER or A equals Pert, your initial amount is that first thing. So in this case, it's A. Your decay factor is always going to be a half because it's a half-life. It's cutting something in half. X is your time, and then H is a constant that's going to be given to you. That's the bottom number. You'll have it. Okay. So this is saying like, how long does it take for, in this case, barium 142 to decay, okay, to certain amounts or after certain amounts of time. So this one says barium 142 has a half-life, okay, that's the half-life of 10 minutes. That's this number, that's the H up here. So 10 is always going to go on the bottom for this problem. It says write an equation for a 20 milligram sample. So if we have a 20 milligram sample, that's our initial amount. So that 20, that's going to be your A. So it's going to be Y equals 20 times, this one's always a half because it's half-life. And then we don't know the time. It just says write the equation for it. So it's going to be X over 10. Okay, the time is still our unknown. So that's going to be our equation, and we're going to use that all the way through this problem. The first question they ask is how much is left after 1 minute? So if T if X is our time, then that 1 is going to go in its place. So it's going to be Y equals 20 times. I typically just plug in 0.5. You can do 1/2. It's not a problem, but you don't need to. You can just do 0.5. So if I plug that into my calculator, I'm going to do 20 times 0.5, and then your little caret key to make your exponent, and then 1 divided by 10. When you hit enter, you should be getting 18.66065 and so on and so forth. So that's 18.7 if we round to the nearest 10th milligrams. Okay. It says what percent is left after 1 minute. So this is how much was left. What percent is that? It's just like finding how you did on a test. The total we started with was 20. What we got is 18.7. So just like you do on a test, I got 19 out of 20 on that quiz. So you do 19 divided by 20. Well, we're going to do 18.7 divided by 20. And when we do that, we get 93.5%. If you left it as if you didn't round, so if it was 18.666, it would be like 93.3%. I'm fine with either one. The rounded is fine. Okay. Oh, my lights just went off. Then it says how much is left after 5 minutes. Here's what I would do on your calculator. If you go second enter and then second enter again, because you probably just plugged in 18.7 divided by 20, you should be getting what was the last entry on your calculator. Don't retype it in every time. You don't need to do that. Just go back, arrow over, and just change that 1 to a 5. Okay. Again, if you need help on how to do that, shoot me an email. I will show you, or I can show you in class later. So when you plug that in, 20 times 0.5 to the 5/10, you can plug 5/10 in as 1/2 if you like that better. That's fine too. So 20 times 0.5 to the 5/10, or the 1/2, they're the same thing. You get 14.14 milligrams. Okay. 14.1, 14.14. Just pay attention to where they ask you to round to on these. We'll specify. Okay, so then it says how much is left after 10 minutes. Again, go back to your calculator. Second, enter. It should pull up your last equation. Go over to the 5 and make it a 10. You might have to do insert or it'll go over top. Or 10 over 10 is just 1, right? So you could just ditch the power altogether. You should get 10 milligrams. So it's 20 times 0.5 to the 10 over 10, which is really just 20 times 0.5, which is 10 milligrams. Okay. Then it says how much is left after 1 hour. Notice everything has been minutes. So we don't want to plug a 1 in here or it's going to think we mean 1 minute. So we're going to do 20 times 0.5. And now we have to do it in terms of minutes, 60 over 10. Okay. When you plug that in, you get 0.3125 milligrams. Okay. So what was 20 milligrams only has 0.3 left after an hour. Okay. That's a quick half-life, 10 minutes. Every 10 minutes, it's getting cut in half. That's a short time to be cutting something in half. Basically what's happening, this is exponential, right? You're starting at 20 and it's just going to drop like that, but never go to 0, right? Because it's always being cut in half. So there's always something there to cut in half, to cut in half, to cut in half. It gets real teeny. Okay, that's what I have for you.